Okay guys, welcome back to my YouTube channel. And I think it's been a while since I make videos for my YouTube channel. And I think this is going to be the first one in 2026. So I just did an Atcoder contest, and it's an Atcoder beginner contest. So without further ado, let's just see the problem. Okay, so the problem is called count subgrid sum equals to k. So here's the problem statement. So there's a grid, and each cell contains an integer 0 or 1. And then the information for the integer is written as h string of s1 s2 until sh. So the input is like you have like h strings, and then like the length would be w. Okay, so what we need to find is a subgrid that has the sum equals to k. So what does sum means here? So what sum means here is that you you need to find the number of ones, and then you need to check whether it equals to k or not. Okay, so the idea for this problem is actually quite simple, but it's quite tricky if you don't notice it. Okay, so the way we do it is that maybe I should open the problem again. We need to see that the constraint is 1 and 500 inclusive. So h can be 1 until 500, and then w can be 1 until 500. So this enables us to have like n to the power of 3 solution. So we can have this. So the way we do this is that let's say we can fix like in a row, right? We have like row 1 and row 2 point here. Okay, so let's say we have something like this. We have like a grid. So we need to fix like a random point in a row here. Let's say it's like this: 1 2 3 1 2 3. Let's say something like this. Let's say we fix this one r1 and then r2. Okay, so the way we do this is that we can find from top to bottom like the number of squares that has the sum equals to k. So I think I'll just explain later in the implementation more. But the way we do this is just that, no, the way it works is like you can just use two pointers here. So we brute force r1 and r2. It will take on squared for this one, and then we have a if we have another pointer which will take like on. So it will be like o to the on to the power of 3. Okay, so let's just see my solution here. So let me open it. Yeah. Okay. So my solution is that I will also use prefix sum. Why? Because if you notice, we need to find the sum between this point and this point for every row. So when we are going down here, when we are going down, we need to retrieve the sum in O1 so that we don't get another ON factor. Okay. So basically, I will just input, and then I will just make the prefix sum for each row, and then later I will have integer of answer. Okay, so I will just make a mapping of the sum. We'll not use unordered map or map because it's very slow. Like if you notice, when I open this, I got like 2 or 3 TLE. It's because of using map and unordered map. Okay, so yes, these two will be the R1 and R2. So we fix 2 points on the horizontal line, and then we have the sum, and then I forgot to erase this, but I didn't use any R here, so I'm using this R. Okay, so we have like MP0 equals to 1. So in a sense, like we are trying to like, okay, maybe I'll just explain it later in this part, but but we need to make sure that we have like one one array that has like zero sum. Okay, so we have the pointer r, so this one is going down, as you can see, 0 until n, and then we have the sum equals to prefix rj. So in a sense, like if let's say we want to have the prefix of like this, right? Let's say we have like r1 here and then r2 here. So the way we can retrieve this is that we can use like prefix r2 minus prefix r1 minus 1. So we need to have like inclusion exclusion, so we can sum this minus sum this, but like it's right before R1, so that's why it's like R1 minus 1, because it's inclusive of R1 and R2. Okay, yeah, so I will just check so that it will not go like out of bounds. And then later, if we have the sum more than equal to k, then we have like answer plus mp sum minus k. So in a sense, it's like this. Let's say we go down, right, and then the sum kinds of overshoot. So the way we can do this is that we can find how many sub arrays, or like subgrids, I guess. Subgrids that has like the sum minus k. It's like, to make sum equals to k, we need to like remove some of the top top part by sum minus k. So yes, that's like the intuition behind this. And then whenever we encounter a sum here, we will just add to the map. And then I will just add another one just to make sure, something like that. Yeah. And then we just print the answer. Okay, I think that's all for my video. Hopefully you like my video, and don't forget to subscribe. I think I'll start making videos regularly now. I will just like continue making videos when I have the time to join a contest. Okay, so thanks for watching and see you in the next video.